So today we will start with the word search problem. We were in the backtracking topic, so let's see. Okay, so the word search problem. We are given a into n grid of characters, board, and a string word, and return true if word exists in this grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. Okay, so we have this board, I'm into n board, and we need to find this word in this board. So this is a word search problem. So A B C C E D. So the yellow boxes represents this word A B C C E D, and we can uh, iterate one box only, means one cell only once, and we can move horizontally and vertically, means we can move in four directions: up, down, left, and right. And we need to check whether the given word exists in this board or it doesn't exist in this board. If it exists, then we need to return true, otherwise we need to return false. For example, abcb doesn't exist in this board, so we are returning false here, and word SEE is present in this board, so we return true here. So let's see constraints. So our board is at max can be 6 into 6 size, means 36 cells can be at max present in this, and word length is smaller than 15, and it will consist of only lowercase and uppercase English letters. So what we can do is we can start from every letter, means we will start from this A and we'll look for this word. If this word we don't find this word, then we can start from, suppose the next letter B, we can start from B and look for that word, means moving in all directions. Okay, so we can use, what we can do is we can start from every letter, and we can either take that letter or we can skip that letter. So what we need to do is let's call a utility function, and we will pass this board in our utility function and this word. So initially in our word we are at 0th index, and we are considering ourselves at the this cell will have 0 0 0. This cell will be 0 0. So we have this board, character board. We are at idx index in our word, means we are searching for this letter initially, this character initially, and we are in this jth cell in ith row and jth column. Okay, so whenever our idx reaches, so we also need to put our word here. So whenever our index reaches word dot length, that means we have found our word, means we have found all the letters of the word, and we can simply return true. Let's make this function data type as boolean, so we can return true. So initially we are in this cell. So what we can do is we can skip this cell uh, on if this first letter matches this a, then also we can skip this letter, that maybe the next letter is not b. So means this a in starting doesn't necessarily mean we should pick this a. So first we will write our skipping step. So in skipping step, what we will do, we will pass the board, we will pass the word as it is, and we will not increment index, because we are skipping this a and we are still looking for our word. So if we are skipping any word, we skipping any character, we need to start from 0th index again, and we will while skipping we can move to the right direction, the below direction, the above, and the left direction. So let's quickly define our directions array, means we can move in 4 directions. So we will define a direction array. So after before skipping this, we can move into 4 directions. So how we will use this array to decide directions? So we will iterate over every pair in this directions array using dir. So our x will be our current index plus dir of 0. int y will be j plus dir of 1. So what does this means? How we are deciding? So initially our dir will be -1 and 0, and our I variable will be 0. So 0 plus -1, which gives us -1, and our j will be 0, and our this value is also 0, so 0. So this means we should move to -1 and 0 direction, so this is not valid. So how we will be moving to b position? So using this, when we iterate over this tuple, what we will do, we will so initially our I is 0, we will add into I 1, which is this, so this will give us 1. Okay, we are incrementing in row, and then in y we will add 0, so we have moved to position 1 0. So which position is 1 0? So s is 1 0 position, and using this tuple we will move to b position. So this will help us in moving all 4 directions. Okay, so before moving to directions, we will check if our x value is greater than equal to 0 and y value is also greater than equal to 0, and our what we can say, x value is smaller than board dot length glmgth. Okay, and y value is smaller than board 0 dot length, then we can move to that direction. So we will call our utility function here, means after skipping this a, we can move to all 4 directions. So what we will do, we will pass our x and y here. So if our this utility functions returns true, that means we have found a path and we can return true. So this was our skipping part. What if we decide to take a value? So we can take a value only if the value present in character present in ijth cell becomes equal to words character at idx position. So for this case, our idx is 0, this is 0, initially our cells are 0 and 0, so this condition will pass that our this a matches this a, so we can take this a. So this is the take part. So if we take a value, then we move. After taking a value, we also can move to all the 4 directions. So we will copy this part. We can move to all the 4 directions. I think I need to have this part. Okay, we can move to, and we will check similar checks here, but instead of reinitializing our index, we will move our index one position ahead, and at the end we can return false. But we are missing one thing here, that we are not marking our cells as visited. So if we moved from this A to this B, then from this B we can also move to this A again, because we are moving into all four directions. So we also need to have a visited array, visited boolean array, which will keep track of indexes we have visited. So this will have same dimensions as of this board. Okay, so we can pass our visited array here. Boolean array, let's call this as a visited array, and after we take a value, we can mark that value as visited. Means if our value matches, means we have considered that value, means we can mark this A as visited. So we can mark visited of ij as true. So after visiting all its possibility and coming again to A, we can unmark it from visited. So that will be backtracking part. We can again mark it as not visited. And before moving to a cell, we can check whether it's not visited, then we will only visit that cell. Okay, and also in these calls we need to pass the visited. And after skipping a cell, we can say that we are reinitializing, means we are now back to zero, means we now again need to search our whole world. So we can consider that nothing is visited, so we can pass a new visited array, means we can clear our visited array. So I think, let's see if this works. We will return this utility function. Surely we will have some syntax error. Here it is. So let's solve the errors one by one. We have so many of them. So first one is this should be a array of array. Then this is also dir is a array. Okay, then we have some error in here, new boolean. So it would be like let's run and see if this works. Okay, we have a error here, incompatible type cannot be converted to. Okay, we are, I think, not taking as a array of array as visited. Okay, so okay, we are getting a runtime error. Okay, our recursion is not ending here. We need to see what is going wrong. Okay, we have some issue in recursion, means if we are marking unvisited, then our skipping function is this function is getting stuck into previous calls. Okay, I think we should have discussed the approach before implementing it. I think this skip function is causing an issue. What we have done is should have done is mm, we should have initialized, let's say first we initialize variables. we have to repeatedly use this variable, so we should initialize this at first. Okay, so why not we should first we should start from every cell. J smaller than m, j plus plus. Okay, this is m, this is I, and this is j. Okay, I think this should work now, because our skip function was causing a issue. Means we were reinitializing our visited array, and then we are getting stuck in the uh, loop that we were revisiting the elements we have previously visited. So instead of skipping, we are search initializing our search from every cell and trying to figure out the approach. Let's run this. Okay, we are getting false. We are getting false for almost every case. For every case. Okay, we are starting from this position in word, and I and j -1 0 -1 1 0 0 1. These are all the directions. Okay, if this word matches with this character, Okay. Suppose we are matching last character. We are at D position, and if that character matches, and it will be not possible that the all the next characters will match. Mm, okay. Instead of making these checks here, we can call this function. Okay, and we can. Mm, this will be here. We can call this function, and if already if our this I is smaller than 0 and j is smaller than 0, or our let's say I is greater than board dot length board dot length, or our j is greater than board dot length board 0 dot length, or our visited is of ij, then that case we can return false, but till that we can return true. We were restricting our call here itself, so I think that was causing the issue. Let's see if this works. Okay, so this is working now. Let's try to submit this, see if this gives TLE. Okay, the approach is working. So what mistake we were doing is let me undo what changes we have made. Okay, so suppose if here our D character matches this D, we were at the last index of matching, means this board ij matches this index, means the last index. So in that case what we will do, we will mark it as true, and visited mark it as true dth position, and we will iterate all its neighbors, and what if this conditions not doesn't met for these neighbor, then in that case we will never reach this condition, means we will never increment our index plus 1, which will means this condition will never met. But which is simply contrary that we have found the solution. So that is why I think, means that is why this was giving a error. So let's see if this solution has some better approach. Simple Java. Okay. Okay, so I think this is the correct approach we are using. All the four direction we are iterating, but we are using a directions variable in doing so. So I think this approach works good. Or we can look for any other approaches. Okay, this is also same approach. Okay, so I think we are done with solution, this solution word search. Thank you.